let's look at this next question. Okay, when I look at left side and right side on this one, it's a little bit harder for me to decide which side is the most complicated. Now, the last time I did left side, so this time I'm going to try to do right side. Now, as I said, they both look pretty yucky to me. I don't know really quite where to start. So the first thing I'm going to do is I'm going to say I'm going to be working with the right side. And then my reasons will be over to the right of that. And then a line down. And that wasn't a very good line because I think I switched it. I know, you just get so much fun out of me doing that anyways, I'm sure of it. All right, try it again. Purple. There we go. So I'm going to start with copying down that side. And as I said, I'm not quite sure what I want to do there. So right side is 1 minus cos theta over sine theta. Now when I look at this, I'm thinking somehow I have to get coses on the denominator because I'm comparing it to the side I want, and I need sines on the top, and I need positive and not negative with the cos. So what I'm going to do is I'm going to multiply by 1. Now, the one I'm going to be multiplying by is going to be 1 plus cos theta. And you'll see in a moment why I did that. So I'm just multiplying by 1. So whatever I do to the top, I do to the bottom. So my reason that I'm allowed to do that is multiply by 1. Now look what happens. This is, and I'll just recopy it for you so you can see, this is actually a difference of squares is what's going to happen on the bottom, or sorry, on the top. And I'm going to recopy this down here, so I'm just actually multiplying. Now if you look what's happened, before I go any further, now I have 1 plus cos theta on the bottom, and that's kind of what I need in order to get to the left side. So what did I just do there? I just multiplied. Now I'm going to actually distribute this through, and you should see that what will come out is, because both brackets are the same, one's positive, one's negative, so really what I have there is 1 minus cos squared theta. So my reason, you can do difference of squares if you want. I think that's what I'll do. Diff of squares. Now I recognize this top as being the Pythagorean identity, the one that said sine squared theta equals. So I'm going to replace this then. So this is actually sine squared theta. And the reason I could do that is that's the Pyth identity. Pythagorean identity. So now what I do is I can see, and this comes from when we actually did uh, rational expressions. I have two signs up here, so that means I'm going to take out that one and cancel it with that one. So what I actually did was just canceling And what I have now on my top is sine theta over 1 plus cos theta. And if you actually look at the top, what we started with, or what we wanted to get, we now have, in this case, the left side. So this equals the left side. Therefore, sine theta over 1 plus cos theta does equal, and I believe it was 1 minus, yep, 1 minus cos theta over sine theta. Okay, so a few different processes in that one. Okay, so let's look at another one together. Okay, the next one has some reciprocal functions here, and we have cotan squared theta equals cosecant squared theta. Okay, so I don't like either side, by the way. I prefer to work in primary, but that's fine. So I think if I'm looking at these two sides, I think in this case too, I'm going to choose the right side because there's two terms instead of one. That's really my only reason. So I'm going to tell everyone that I'm working on the right side. And over here is going to be my reasons. And I'm just going to do this instead of waiting for me to draw a really nice line. I'll do a squiggly line, which I didn't want it to squiggle that much. Okay, so cosecant squared theta minus 1 is what I'm starting with. Well, the first thing that I see that is I'm going to change cosecant squared theta to 1 over sine squared theta. Okay, so I am actually going to do a substitution. Okay, so what I did is I did recip ID. Now, as soon as I did that, I noticed now I have a fraction. Ah, yes, so I want to find a common denominator between these two. So that's going to be, my common denominator is going to be sine squared theta. This term stays as 1, and this one is going to then be sine squared theta, right? Because if I multiply the bottom by sine squared theta, I must multiply the top. So all we did there was find a common denominator. I recognize this as being cos squared theta. So over here, I am going to put, it's the Pyth identity. Oops. Now, what do we do with this? Well, you can see, hopefully you can see, so this isn't part of the proof. Remember that I know that tan squared theta equals sine squared theta over cos squared theta. Okay, so this has been flipped around. So in fact, what this is, you can either put this as being, I was thinking you could put it as 1 over tan squared theta, if you so wish, or I would accept, okay, so you could do that, or you could just automatically put that equals cotan squared theta, and the reason being is the quotient identity. Which then would give us equaling to the left side. Okay, so that step there, I think I would take, as I said, either from there right to the cotan squared theta, or you could do this and then you would have to flip it around again. So I don't see too much difference between that. So I'm just going to move this out of the way because I now have it equal to left side and I have to finish it by going clone. Oops. You're saying that's cheating. Yes, it is cheating, I know. But that's the fun part about being a teacher. I can cheat just a little bit. So I just need to put therefore cotan squared theta equals cosecant squared theta minus 1. Okay, so those are 3 questions that I normally would do in a lesson on the blackboard. Um, the next 2, it's going to leave totally up to you whether you do them or not. Just these are 2 that I haven't looked at and the process that I would go through if I was doing it. Everyone sees things slightly different, and although I solved each one of these identities a certain way, doesn't mean to say that there aren't other ways that you could do it. So I'm going to pause this video. Actually, I'm going to stop this video, and then as I said, there is a part C if you so wish to watch it.